Hello everyone, my name is Emily Pujoli da Silva, and today we're going to talk about our proposed framework for recognition of facial expression on sign language application. The main contributions of our paper is the survey in Brazilian Sign Language facial expressions and the framework for facial expression recognition applied to Brazilian Sign Language. Facial expressions in sign language represents morphemes that fulfill syntactic and pragmatic functions, besides communicating affective states. For that reason, the problem of recognizing facial expressions in sign language context can be considered more complex than the typical affective computing problem. A first contribution of our work was to conduct a detailed survey of existing facial expressions in Brazilian Sign Language, also called Libras, which is our language of study. We encountered a large number of facial expressions that could be further organized into classes. The two large ones are affective facial expressions and grammatical facial expressions. Additionally, grammatical facial expressions can be further divided into sentences, intensity, homonymy, and norm, accordingly with their function in the discourse. However, there is still a lack of pattern in the terminologies of facial expression in Libras. In this work, we propose to code facial expressions of Libras using the facial action coding system. Due to our limited access to examples of all facial expressions of Libras, we limited our model on the grammatical facial expressions of sentence class, and for the affective class, we adopted the prototypical 7 basic emotions. Let's talk about the framework we use to build and train our Libras facial expression recognition model. Starting with data, we use the first database of Libras with action unit annotations. The head movement in Libras database is composed with videos of deaf individuals and intérpretes performing 80 sentences in Libras. Next, let's discuss our proposed preprocessing stage. Given an input image, the face and landmarks are extracted. The face is segmented in upper and lower part, then further added geometrical features obtained from the landmarks. With the preprocessing stage established, we consisted on training and testing two network models. The first one is a basic convolutional neural network architecture. The other architecture is a hybrid network with LSTM on top of a CNN. Now, here are some experimental results as a first case study. In the experimental setting, we compare the proposed CNN and the CNN plus LSTM against AlexNet and VGG16. Both were adapted for the classification model by modifying the input and output layers. All networks were trained with a percentage of HM Libras combined with CK Plus and GISFA databases. The test set was composed only with HM Libras videos. By comparison with these benchmarks, our CNN-based framework outperformed all models. Our next task was compare the CNN-based framework with a human transcription of Libras grammatical facial expression class. We got fair to moderate confidence from Kappa's coefficient when our recognition model is compared to human annotation. In general, our results implies that learning facial expression of Libras as a function of action units may be more accurate and systematic way than learning facial expressions from the whole face. Thank you for your attention.